In section 5-2, you learned about perpendicular and angle bisectors. In this section, section 5-3, we'll talk about how those bisectors are related in triangles. Now, before we do that, there's a very important vocabulary word that we need to cover. Okay, a word you should be familiar with is the word intersect. So when two lines cross, we say they intersect. Now, when three or more lines intersect at the same point, we say that those lines are concurrent. Okay, and lines being concurrent is a very important vocabulary word for this section. Now, we'll begin by talking about perpendicular bisectors, and before I give you the theorem, I want to show you a Geometry Sketchpad file. This is a triangle, and I will draw in the perpendicular bisector of segment AB. Okay, and this is the perpendicular bisector of segment AC. Okay, you'll see that they always intersect. And this is the perpendicular bisector of segment CB. Now, the first thing you'll notice is that they are concurrent. Okay, they cross at the same point, that they're concurrent. Okay, you'll also notice that that point of concurrency can be inside, it can be on, or outside the triangle. Okay, it's inside the triangle when it's an acute triangle. It's on the triangle when it's a right triangle, and it's outside the triangle when it's an obtuse triangle. Okay, and that'll be in the slides later on, but I want to show that to you right now. Okay, now this point of concurrency has a name, and it's called the circumcenter of the triangle. Okay, now the circumcenter has another really interesting characteristic, is that it is the same distance away from each of the three vertices. Okay, so if you notice, however I move this, that the distance between that point and the three vertices is always the same. Okay, so let me show you the perpendicular bisector theorem. It says that the perpendicular bisectors are concurrent. Okay, it says the perpendicular bisectors of the sides of the triangles are concurrent at a point equidistant from all the vertices, meaning the same distance from all the vertices. Okay, and that's the concurrency of perpendicular bisectors theorem. Okay, like I mentioned before, that point of concurrency is called the circumcenter. Okay, and another interesting vocabulary word is that we could say that the circle is circumscribed about the triangle, meaning if we put a circle with center at that circumcenter, then the circle will go through the three vertices because they're the same distance away. Okay, and the way I remember the circumcenter is because the circumference, now those words sound similar to me, the circumference is on the outside of the circle. Okay, so the center of that circle is called the circumcenter. Also, like I mentioned before, the circumcenter can be inside the triangle when it's an acute triangle. It'll be on the triangle when it's a right triangle, and outside the triangle when it's an obtuse triangle. So here's a problem that I want to do together. The question is, what are the coordinates of the circumcenter of the triangle with vertices 0, 6, 0, 0, and 4, 0? So I'm going to plot those points. First, the point 0, 6 is right here. It's point P. The point 0, 0 is point O. And the point 4, 0 is point S. Okay, I will draw those in to make a triangle. Okay, the way we find the circumcenter is it's the perpendicular bisectors of all three sides. Okay, but since they're concurrent, I only need to use two of them. Okay, so I'll pick the horizontal and the vertical ones because I think that'd be easiest. I'll start off with this one. Now, it's going to be perpendicular, so it'll be vertical. Okay, and it'll be a bisector, so it's right in the middle, right here. So this is the perpendicular bisector of OS. Now looking at OP, perpendicular to OP will be horizontal, and it'll be right in the middle, which will be about here. And so this is the perpendicular bisector of OP. Okay. Now they intersect at this point right here. Okay, which notice that it's on the triangle, and that happens because this is a right triangle. So the point of concurrency, or the circumcenter, is the point 2, 3. The next problem I want to look at is a town planner wants to locate a new fire station equidistant from the elementary, middle, and high schools. Where should he locate the station? Okay, so he's looking for a place that's the same distance away from 3 points. Well, the circumcenter is that point that's the same distance away from the 3 points. So what I'll do to solve this problem is to make a triangle out of these 3 points. Okay, and find this circumcenter by finding the perpendicular bisectors of the 3 sides. Now I'll just sketch it out, although I could use a compass or a ruler and a protractor, but I'll kind of just sketch out the perpendicular bisector. So the perpendicular bisector of HM is about right there, and the perpendicular bisector of HE looks to be about right there. Okay. Now I could draw on the third one, but I don't need to since they're concurrent, and the fire station should be located somewhere around here. Okay, and that point will be the same distance away from the 3 points because it's the circumcenter.